empower, automate, digitize. In this episode of the Omega Podcast, we have a building automation consultant, Robert Gillette, discussing with our founder, Keenan Thomas, on building automation, 2D and 3D design simulations, and building design integrations, and much more. Digitized for excellence.
Welcome to the Omega Expert Chat with Robert Gillette, who is a building automation consultant at Advantage Power and Control. With over 30 years of HVAC controls experience as a project manager, engineer, programmer, and designer, he also served in the United States Marine Corps as an Avionics Technician. He is currently an entrepreneur developing a company to break into the building automation system market with over 20 years of experience of building automation and growing. Robert, it's great to have you on the podcast.
How are you?
I am doing well now that you're here, Robert. It's been very long since we last chatted, but it's great to see you and to have you here.
Same here. Same here. I'm happy to be here.
Awesome. Well, I'm really looking forward to our conversation on building automation, understanding the different intricacies of what that particularly is and how we can shed light to the business owners and leaders across the world on how they can leverage building automation for their business growth.
Sure.
But to start off, what is building automation?
Building automation. Take a building, an office building, a hospital, a school, whatever. You can have just a regular standalone thermostat, but then you can have a programmable thermostat. But then you can take that and go further with operating the lighting, operating the environment of the building, load shedding the energy. Building automation started over 100 years ago. And instead of using wires, they used pneumatics. They used air pressure in quarter-inch tubing throughout the building. And those air pressure lines were controlled by a thermostat that either bled the air off or plugged the hole and let the air pressure build up. And as the thermostat operated, if the room needed heating, it would bleed the air off the line, which would open a valve on a spring. It would take a diaphragm and open a spring. That's called pneumatics. That started over 100 years ago, so that in a building, if I wanted to cut the heat back on a building at nighttime, all I had to do was change the whole pressure of the building from 20 pounds down to 17, actually raise the pressure from 20 up to 25. And then, when I went back to occupied, I would bring the whole constant pressure back down to 20, which would, all the valves in the building would linearly act accordingly. So that was one of the first building automation systems that was it was actually invented by Johnson Controls. And then from there, you now started getting more complicated with controlling temperature, humidity, pressure of buildings, labs, and it was all done with pneumatics. Well, pneumatics over time has become antiquated. And there's still hospitals out there. There are still schools out there that I still am cutting over from pneumatics that are well over 75 years old. And now we're going DDC, which is direct digital control, which is now you replace those pneumatic valves with an actuator. You now have motors that can slow down and speed up. You have boilers that just aren't on off. I can maintain a 17% flame or a 97% flame on my boiler. I can turn the lighting down in my building. I can control the security in my building. I can have a clean room. I can have a patient room in a hospital where, let's say, one patient has a disease or has a sickness where they can't have anything get in that room because it could kill them. So you have to have that room in a positive pressure. But then let's say that patient goes home and another patient comes in and they are now the disease. They have the Ebola virus. Now I have to make that room negative pressure so that their disease can't get under the door out to everybody else. So, and you can make the pressure of that room negative or positive based on what the nurses need to set it at. That's just like one out of a million examples of building automation. All of this comes back to a central nervous system, or basically called a supervisory controller. That supervisory controller then may be connected to other supervisory controllers. And then all these come with graphics, alarms, schedules, trending, so, you can take your buildings and you can make them automated to where, based on the outdoor temperature, the inside of the building and the humidity, the inside of the building will maintain what it's designed to do. So that's kind of what building automation is controlling the environment, not just temperature, but controlling the environment in a building, the building humidity, temperature, and pressure, but also lighting. You can control security, door keys. And there are many systems that are now being offered on the markets. And they all communicate on protocols such as BACnet, LAN, N2. So there's different communication protocols. BACnet is the industry standard according to ASHRAE, though. So that's the short answer.
Yeah, no, it's very enlightening. I think it's an extremely exciting profession to be in because of the insulation of automation, the different procedures, as you mentioned in your response, HVAC, controlling the building environment, the electrical wiring, the line voltage, the lighting. You even touch upon that there is a bit of an IT framework and architecture that has to go into it when it comes to just alarming the different individuals on the back end to be able to receive the responses when certain areas within the building are working properly or not working properly. But what I find to be the most fascinating part, and one thing that you also mentioned in your first response was, automation is practically a fairly broad term in the business context. I mean, you can talk about AI, you can talk about different generative tools that have come out within the recent years. However, when it comes to building automation for labs, schools, high-rise buildings, it's really increasing at a parabolic rate. What particular technologies can users or individuals within the BaaS market anticipate future systems features to have?
It's a tough question to answer because if I blink my eyes and 3 weeks goes by or 3 months goes by, something new comes out on the market. It is now getting, how do I answer this? To look towards the future, you have to almost look at a building as a living thing, and you have to engineer what the personalities of that building are going to be and who's going to be in that building, and what that building's going to do in 10 years. I mean, take a building right now and make it an office building, and then 10 years from now, you may have people that want to come in and renovate certain sections of it and move in. And okay, now this is going to be Quest Laboratories that does blood work. This is going to be, then this other section will be, a lab. And then this other section might be just offices. Then this next section is going to be attorneys. So are you going to have a building that's going to be flexible, or are you going to have a building that's going to be dedicated to what it's engineered to do? And then you have to figure, you have to figure out what classification these buildings come under. Is it going to be residential, commercial, industrial, institutional? So an example is with institutional, people that are in there as patients or prisoners, they can't get out. So if you're controlling the environment of something, you have to make sure that you have backups, safety protocols. If I've got to bring a certain amount of outside air in and that air handler goes down, you have to have a whole nother air handler that's just sitting there doing nothing, ready to go to bring air in. Or if there's a fire, to, stairwell pressurization to get, smoke out of the stairwells and pressurize the floor and sandwich it so the police can, the firemen can come in and do what they need to do. Building automation can interlock to the firefighter override panel in the front of a high-rise building, so that if the fire's on the 27th floor, the firefighters can go to that panel at the front and they can pressurize the 25th floor, pressurize the 23rd floor, and sandwich that fire and isolate it on the 24th floor. They can control all that, then send their guys up and get people out of the building. That's just an example of, fire safety. So it depends on your building. What kind of, I've got a college campus where I'm doing the whole campus. I've got probably, 20 buildings on building automation. I have multiple supervisory controllers all going back to a server. And all that's automated so that the facilities folks that are repairing and up and maintaining the equipment, they get their emails, they get texts, alarms saying, okay, this building just went down, or this pump just went down, but the other one came on, it automatically changed over. We're good to go for the night, but somebody has to come in the morning and check pump number 3 because pump 4 just decided to die, and we don't know why. But I got an email, I got a text saying what's going on. Yeah. So looking towards the future, it's hard to predict that because I've seen things come along I never would have thought would have been on building automation 20 years ago. And now I'm like, wow. Lighting is a huge one. Lighting is huge. Lighting is a huge energy on a building. Especially take a Kmart, look up, or a Walmart. How many lights do you see in the ceiling? Every single one of those lights is probably drawing, half an amp or 1 amp. Now all those lights can be LEDs and put out the same amount of lumens, and they can all run on Cat 6 wire. They don't have to have 277 volts or 120 volts or 220 volts run to them. They run off of a server switch, and a server switch has enough power to power all the lights in a Walmart. That's insane. That's insane. So that's the future. You didn't see that 20 years ago. That wasn't available 20 years ago. Now that's happening every day.
Yeah. And I think it's so important that we understand that all of this is by design. It's very important that we understand that there's a blueprint, that there is a process, that your engineers, your developers, your graphic designers are all coming together, working as one in order to ensure.
And that's just it too. That's just it, is the blueprints that come out now, the new jobs that are going in, and the renovations all have to adhere to new codes that require to have a certain amount of energy savings. You have LEED certifications, which, basically get you rebates or get you savings on energy that your building is using. And, with that, this plan, the specifications and the plans written for every job I come across now all have built-in automation. It used to be, even 10 years ago, 15 years ago, it was like, oh, we can do that with local controls. Oh, we can just do that with a thermostat. It's not allowed anymore. It's not allowed anymore. You have to put in something that has either a night setback or a way to, adjust the temperature of like a boiler loop in a building, where I don't need to maintain 180-degree water temp in an entire building out for radiators on a 50-degree day. I can bring that down to 110 and still maintain that and save gas on my boilers. So and all of that is now required, and it's not something that's specifically being taught in colleges or in a lot of vocational schools or in high schools. It's you fall into the trade.
Interested in being a guest on the Omega podcast? Call our international team at 617-203-2080. Accelerate with Omega.
Right. And on that point, we talked a lot about the complexities of these processes. What are some key elements engineers, graphic designers, and these types of implementers should consider when designing these types of building automation sequences? You mentioned safety protocol, you mentioned compliance, but are there anything else that you think would be highly considered?
Yes, what the client wants, what the owner of the building wants. A lot of times I'll see something engineered one way, and that was not the intent of what the client had. Now, the client or the owner of the building may not understand the code or may not understand that, they can't do certain things that don't make something energy efficient. But on the flip side of the coin, the engineer also has to meet the needs of why the building's being built or why it's being renovated. Out on Nantucket, there's a resort out there. They don't care about being energy efficient so much as they care about if the pumps go down or the cooling tower goes down, then on a Tuesday, if they're charging $1,000 a night and there's 32 suites in that building and that goes down, that's $32,000 they have to give back because nobody had their air conditioning running. And that's all because a pump tripped the breaker. And if there's no building automation, then by the time that gets to the maintenance guy and he drives out there and then he fixes it and gets it back online, people have now been uncomfortable and they want their money back. But on building automation, first thing would happen is the other pump would start automatically. But if let's say that the other pump didn't start, at least that guy would get a text message on his phone saying, hey, the pump just went down. Somebody needs to get out there right now. And within 15 minutes, they could drive there and have it up and nobody would have known. And they would have still been comfortable. You know, so you know, there was a wedding out there. It was a $500,000 wedding, and the water pump went, the well went. They had no water. The brides couldn't get clean. They couldn't get their makeup on. They had to transport everybody across the island to another resort to get their the wedding party to for the needs of what they needed. And we installed some building automation out there that let their pumps rotate automatically. If one went down, then the well pump, another well pump come on. Somebody would get an email. They could fix it quicker. Right. They could get a resolution quicker. It saved them tens of thousands of dollars a month just in maintenance calls.
Exactly. And that actually bleeds into the next question. You know, how should consultants best approach strategizing with small and medium-sized companies on integrating building automation? You know, there's a lot of associated energy costs, you know, maintenance costs that can be lowered due to implementing automation procedures. But what are some of the savings that you mentioned earlier, or maybe some others that can be achieved?
So you have to find out what that owner of that building's pain is. So is their pain reliability? Is their pain their bills are incredibly high? You got to find out first what the pain is. I had one building in Boston where when you drive by it on a Saturday night at 9 o'clock and you looked over, the building was glowing. The heat was on, the air conditioning was on, the windows were wide open, and all the lights were on. It was a 14-story building right off the highway. And we did an energy project over there where we put in over 140 valves on all the steam radiators. And we took control of all the air conditioning on every floor. And we took control of the lighting and put motion sensors in so that if there was no motion within 15 minutes to a half hour, the lights would automatically shut off. And their bills, from like an example is they would buy steam from Trigen, just like a utility. Steam's a utility. Their steam bill was $14,000 a month. It went down to $7,000 a month. Their electric bill was $20,000 a month. It went down to $9,000 a month. That's a month. Now, that job cost, I think, $210,000 to do all the work we did. Their payback was less than a year and a half. That's insane. That's insane.
Yeah.
You know, and also we put we also put sensors on the wall, on the windows, so that if they did open the window, the AC and the heat would shut off, which hotels are doing now. When you rent a hotel and you have your air conditioning on and you open your sliding glass door to your balcony, the AC now shuts off. Because why am I going to run my AC when somebody has their window open, when they have their sliding door open? You know, pick one. Do you want fresh air or do you want air conditioned air? But we're not going to sit here and burn energy because you want both. And hotels are getting wise to it. Yeah. So those are some reasons.
Yeah, those are very, again, great points that you're bringing up regarding the hospitality sector, you know, buildings that are not utilizing their opportunities when it comes to lowering their energy costs. I think these are all efficient ways that businesses of the future can be able to adapt and to leverage, for instance, even solar energy. Have you integrated solar energy in any particular projects? Do you find that being the energy efficiency that businesses of today could be leveraging to lower those particular costs? Or are you seeing, as you mentioned earlier, lights, HVAC systems being more of an area for opportunity than, for instance, integrating maybe more sustainable options?
When it comes to solar energy, I haven't personally integrated solar energy, but so building automation, when you talk about building automation, BACnet, BACnet is a communication protocol, and it's kind of like a language that talks on the communicating wire. And BACnet can talk over a 3-wire communication bus from one controller to the next, or it can talk over IP. It can talk on an IP address as well. And devices now, you can buy a relay that turns on and off, that's got its own address, and it's a BACnet device. Or you buy controllers that are controlling the plant, or controlling the air handler, or controlling the lighting, or controlling the building pressure. It can be controlling the parking lot lighting. It can be doing the security and then so you can take, and when an example would be is when you register into a hotel and you picked room 303 and your name is assigned to it, and you're going to be assigned to that room for 48 hours, the building automation system that's in that building will automatically take that room and put it into occupied mode. It'll take the thermostat and allow it to be adjustable. It'll limit to how much you can adjust it. Some places you only want to give people a couple, plus or minus 2 or 3 degrees. Others you want to give them full control. Others you don't want any control at all. I mean, the last thing you want to do is put a thermostat in a hallway with 5th graders where they could adjust the temperature. So you put sensors there, right? So when you do these things, so many, more and more companies every day are now getting onto the BACnet protocol. They're providing BACnet cards that come with their boilers, come with their chillers, come with their lighting. Pumps, VFDs. VFD is a variable frequency drive that allows you to slow pumps down, speed them up. It's insane how many different things are coming BACnet capable now. And the future is just going to think of things that you and I haven't even thought of yet. But you could get to the point where you can have windows on a building that can go blank. I push a button and electronically that window, just like you see in science fiction movies, will go black. And then I push another button and now I can see through it. That can be building automation now. So I can take a room and make it dark. And let's say I'm having I'm having some kind of a slideshow in the room or presentation, and there's too much light coming in the window. I can just go over to the wall and hit a button, and now the windows will go black and no light comes in. And now I've got a super dark room. It's the imagination is endless. It's absolutely endless what you can do with your buildings now.
Absolutely.
And your buildings notify you when things are going on. You can log in on your phone. I can log into my phone right now, Dean College, and I can turn the temperature down in the campus center in the cafeteria. I can do that from my phone. A lot of people, a lot of us now are doing these things for our houses, but now this is at our fingertips for entire campuses, the town. I have towns where I'm controlling 20 and 30 buildings in the town. The DPWs, the police stations, the fire stations, the town halls, all the schools, they are now all connected together on one network, controlling the lighting, controlling the security, controlling their temperature, their humidity, their pressure. It's insane. It's absolutely insane.
But it's one of those exciting areas that we can step into for the future. for
It's
what
very exciting. Very
automation
exciting.
is going to be, smart cities, of course. But I do want to get some of maybe your soft skills, because I know obviously you're very technical. You know so much about this particular sector. And I think it's important that for some of our listeners that they understand that you didn't get there by yourself, right? You went through mentorship, people sponsored you, people invested into you. How has mentorship played a key role in your success in this particular market?
I would not be where I'm sitting without so many great people in my life that have mentored me. I started out after I got out of the United States Marine Corps. I started out mentoring under some men where I was so hungry. You have to, you have to be hungry. You have to want the knowledge. And when you'll find out that in this building automation field, every day you find out something you don't know. And you're like, okay, now I got to learn that. You have to have courage, because you have to be able to look at a piece of equipment, something that's new, and say, okay, don't know how this works yet, but I'm going to figure it out. And you've got to read the manual. You've got to talk to the manufacturer. You've got to get some training on it. And that's every day for me. That is absolutely every day. But I've been mentored by so many great people in electrical field, HVAC field, information technologies field, graphics. And, when I was younger, I was hanging out at some of these people's houses. An example would be I have a very dear friend of mine. He was my mentor, and he had like 3 ice machines in his basement, and he had like 10 window air conditioners, and I knew nothing of what I was doing. And he goes, well, why don't you come over and we're going to take some of these apart, and we're going to start learning about, refrigeration and temperatures and pressures, your superheat, your subcool. We're going to learn about how this machine works, what kind of, metering devices we have, and we're going to fix them. So, after I'm done at work, I'm going to their house and I'm hanging out in their basement, and I'm fixing this equipment, fixing these ice machines, fixing this, fixing that. And then when I got further on down the field, I'm always taking courses on the side, or asking somebody, hey, where can I learn this? Can I take this course at a college? Or is this something that's offered by the vendor? Oh, there's so many courses you could take, show up for a 1-day course or show up for a 3-day course by vendors that are free. There is so much free information out there if you're hungry for it. To get into the field and automation field, everybody's story is different. It's not like, oh, I went to college for that, and then, or I went to this company. Everybody's story is different. I know men that have come from, not just men, women too, women and men. I know folks that have come from electrical field, HVAC field, which is heating, ventilation, air conditioning, engineers that, gone to school for engineering and have decided to get into the building automation field. Mass Maritime. I've known firemen. There's so, because building automation touches all of the trades in construction and in the information technology field, with graphics, with actual mechanical equipment out there, with electricity, with DDC controls, with so many things, that if you focus on just one, you have to be more broad-minded. That just gets you in the door. That gets your foot in the door. And let's say you go to school to be an HVAC technician or an electrician, and you do it for like 3 or 4 years, and then you realize, wow, that guy over there, he looks like he's doing something pretty cool, pretty complicated. And I know he's always asking me, like, is the power on yet? And was this wired to this, and was what? I want to know what he does. And then next thing you know, he's like, you know what? That sounds like a really cool field, and I know this part of it. I know the electrical part of it. So now I have to catch up on the others. And this field, you will never be bored. It is continuously feeding you new stuff. If you're a person that has a hungry mind, this is a field you want to be in.
That is fantastic. Well, thank you so much, Robert, for your time, your insight, your intelligence, and for being on the Omega Expert Chat.